Hey guys, welcome back to Man Time. Today's episode, Stihl 056 Part 2. So I'm just tinkering around after work here and thought I'd start playing with this a little bit. I checked the squish. Let's just talk about real quick what is all going to happen with this saw, right? I've got to run a new spark plug wire to that really expensive heavy coil looking thing there. Who knew that was trapped inside of there? That was pretty sweet getting that off of there, wasn't it? I thought I'd make its own video because that was pretty complicated, but I'm actually going to split the case in half. I'm going to replace out the seals on either side of the case. So there's a lot that's going to be involved in this. I'm also going to do some porting on the cylinder. So yeah, let's just jump into it. Welcome to Man Time. So the legendary Stihl 056 AVE. Alright, I wanted to start with some timing numbers and also the squish. Right, so first thing, when I got off work, I checked the squish. The squish was like, say that 5 times fast. Squish was like 50 thousandths. It was horrible. So I took the gasket off. It was like 42 thousandths or something thereabouts. So I did the old 400 grit on the machined surface block here and managed to get 4 thousandths more off of it, so I'm down to 38. You know, nothing super special or legendary there. Lots of room for improvement, but I tried to put this on the lathe, right? I have the 52 millimeter mandrel, put that in there. There's no, the center point is like, the live center is wanting to go like in somewhere around like here, off center, but the point goes in here, but it wants to kick it off to the side once you get in there. Man, I wish I could get these dogs off of there. That thing is going to freaking kill me. So anyways, let's get this zeroed out and then look at the stock timing numbers on it, huh? You excited? I am. Alright, so there's 45, and back around to 45. Dead on 45, a little off of 45. There we go. Alright, 45, 45, good. Okay, so now we take this out. As I take it out, I'm rotating up and then top dead center. Yeah, okay, now we're set. Always good to double check yourself on stuff like that, isn't it? Okay, first ray of light coming through the exhaust, going the rotation of the engine. Yeah, the exhaust isn't exactly uniform either, so we'll call it right there. Let's see here, before bottom dead center, 70, let's see here, 70... I'm going to call that 74. So we're writing everything down. We'll double check that. 74, so 140, 148. Kind of wimpy there. And the exhaust port isn't very wide either. Nice thing about this one, it's got so much wear in it, I can see exactly where the piston rides in relationship. Alright, so first opens right there. Yeah, now I'm seeing 73, so I like 73 better. I mean, I don't like it better, but that's what I'm getting. Anyway. Yeah, 73. I was seeing in between 73 and 74 the first time, so 146. Alright, let's check our below down. We continue down. Oh man, there's like no blowdown. right there. So 50, 58. So 58, 68, 69, 70, 71, 72, 73. So 15. Huh. Yeah, 15. That's pretty anemic. So that's actually good though. I can go way up on the exhaust duration by raising the roof of the exhaust and get more blowdown. So that's good. This is going to be a fun one. Lots to do. Lots to do. Okay, and then let's see, intake. Where does my intake open? Just starts to crack right there at 72. Intake 72 before top dead center. 72, 144 duration. Man, I can go wild on this thing, huh? How cool is that? Okay. While I'm in here, I'm also going to mark some marks on the piston. I've got the layout fluid on that piston. So I'm going to go, let's see here, somewhere right in there, right around 90. So we'll make a mark at 90. And then we'll make a mark at 80. And then we can see how many degrees is equal to how much length. And then I also want to go to top dead center and make a mark on the bottom of the piston here. And actually I did that with the base gasket, so I can actually measure how far I've come off of that. Okay, so I think we've got all of our timing numbers. Now we need to lay it out in the cylinder. Alright, so here on our piston we can get our measurement for the distance of 10 degrees. So let's check from here. Right there. Oh boy. I'm getting dead on 140 thousandths, and that's on this particular one here. You've got 100 and then plus 40. So 140, let's mark that down. 10 degrees is equal to 140 thousandths. Alright, so here's what we got so far. Let's see here, 52 millimeters squish without the base gasket, 0.038, exhaust 73, so we said 146. So let's talk about what we want to get to. Goal. I want 160, 160 something. So in order to get to 160 from 146, 56, so let's see here, 56, 14, so I want roughly 14 degrees of additional duration, which is going to equal to 7 degrees of material removed. And then intake, let's see here, so 7 degrees, what does that mean for blowdown? Blowdown is a direct conversion there, so 7 plus 15, so we've got 22 that would make 22 blowdown. So if I want to get to like 20, I can go all the way up to 23. I may want to work around that goal at 23 duration or 24 duration of blowdown. So then I could go up to like 162 to 164. Let's just write 162 here. That'll give 23 degrees of blowdown. I like that. I think I want to go there. All right, intake. I'm at 144. I want to get to at least. See, the intake and exhaust durations here are really close, and people say the intake should be somewhere around 155 is a safe number. I'm going to bump that up to. I've had good luck with like 158. So we'll shoot for that. And again, it's just, if I'm at 162 and 158, I'm still keeping that ratio of the stock number there, right? So to get to 158, let's see, 144, 154, 5, 6, 7, 8, so 14 additional degrees duration, which is going to equal 7 degrees of material. And from here we can say, all right, 10 degrees is equal to 140, so 1 degree is equal to 14. 1 degree is equal to 0.014, 14 thousandths of an inch. So if I need 7 times 14, let's see, 28, so 98.098 equals 7 degrees right there. Alright, so I'm looking to go just roughly about 100 thousandths off the roof of the intake and the floor. No. Roof of the exhaust, floor of the intake. 0.1 roof exhaust, 0.1 floor intake. Okay. So what does that mean for, like, in terms of actually looking at the cylinder, right? So right here is our floor. That's the roof of the intake, and then the floor of it is right there, right where the flashlight's pointing at, shining through. Right there. The opposite side of the tonsil there. Alright, and then for the exhaust, the roof is this side. On the other side, let's see if we can get a look in there at that. So the floor is toward the spark plug. Sorry, the roof is toward the spark plug. That's where we want to take off material. The roof of the exhaust, 0.1. Alright, so now how do we measure 0.1? Well, we can do it 2 ways. We can put a piston ring in here and run it up to the degree that we want, or we can put a little bit of layout fluid in there and then take our calipers, run this down to where we know is 1/10 of an additional 1/10 of an additional, and then just scribe a little mark in there. Whoa. But I like the piston ring method, actually. So we'll pick up there. I just wanted to demonstrate here the piston ring method to get our port timing. So I've got it back in time here at top dead center. We want to make sure our exhaust is, of course, going the correct direction, and then we'll get it snug down here. And right now I'm pushing that ring up into the cylinder, but I'm, of course, at bottom dead center, so it's not doing anything it's not supposed to be doing, you know. Yeah, the first time I tried this method, it was a little tricky because you've actually got to rotate the piston up into its resting location from the opposite side. So it may take a little bit of maths here to get it to where it's supposed to go, but let's see what we came up with here. We wanted to go with 7 degrees of material, so we were at 73, so we want to go to 80. So we'll just take our cylinder going up toward top dead center and go to 80. There we go, and then back down. And then the check for that, now that we know that 7 degrees of material is equal to about 100 thousandths or 1/10, just looking inside of there, we can see that ring and see if it is actually looking like around 1/10 of an inch, which is, you know, about 1/8 of an inch. These out of there. These out of there. See, yeah, that's what we want. So right in there, you can see the exhaust port and the ring just right above it, and then we can take a Sharpie and mark that line. Nice pointy Sharpie, and just get in there right against the and then we just grind off all the black. One other thing we can see in here, like right down this side, like right here, you can actually see where the piston has been rubbing. You know, the edge of that piston is coming like right in here, right? And so we've got lots of room on either side of that exhaust port to widen it. So I may widen it like 1/10 of an inch also. And I can draw a straight line down from this line, and I want to be, you know, 20 thousandths, or let's see here. Yeah, about 1/10 of an inch off of that as well. So about that much off of the edge of it there. So we'll widen this exhaust port too. Let's see it, but we want to measure down to the edge there. All right, so we are at, oh, that's convenient. So 0.79, 788. So we'll come down 10, yeah, 1/10, so 788. There we go. 1/10 of an inch. The other way. 7/8. Okay, so there we go. See if we can shine the light on that for you guys. So we described the line, so then I'm going to just grind right up to that line. And that should be my 7 degrees. There's the foot pedal. Alright, so let's see here. I want to get everything in a comfortable position. And the first thing I'm going to do is a little bit of work on these transfers. Now let's get some cutting fluid here. First thing I do is a little bit of cutting fluid. This is just ATF because it's easy. And then I just want to try on these transfers here just to see what this plating is going to do. So we'll start here. Yep, plating's acting really good on there. I don't know how well you can see that, but the plating is not even attempting to chip or anything. So I think I'm good there. I'm going to keep hogging away material, and we'll see where we end up. If you're scared, doing something like this with a male Molly Pt2 that, they don't stock anymore, I mean, even start off with just sandpaper on the plating and see what that's going to do. But nice fresh tooling, of course, lube. We'll keep going. Alright, and there's our exhaust after touching it up there. Nice symmetrical D-shaped opening. You can see there, all off of the roof of it. Alright, real quick, just wanted to show you the intake is actually offset this way. And if you look at it here, this is way over here, this is way over here. So on the inside, same thing. I put an X on there to mark that I don't want to cut anything off of this side. We're already there. See, I can take a little bit off of this side here just to make it equal on both sides. Alright, here is our intake, and this is the side, again, where I could go really far over, and I took it about as far as I could. I also made the D-shape favor this side a little bit. I don't know how well you can see that, but and then this side here, give it a little horn, and then this one I just took it all the way as far as I could go, but you can see the line from the piston going right along here. I've still got a long ways I could go, but I'm going to stop right there because that looks pretty darn good, and I'm shooting for a little bit below my numbers. We'll talk about that here in a minute. Let's clean these transfers up. You can see I started right there on that one. Looks good. Plating, grinding awesome. Alright, I think we got it. Now I can just find my head bolts here. There we go. Alright, so here's our finished product. You can see here with the transfers. I went opposite of the intake and just started making a nice even path for those. Opposite of the intake again on this transfer, making a clear shot. So that exhaust gas is coming in here, going down, and then we want it shooting up and back toward the intake. So we want a path through here, through there, again, just flow through there. So we'll see where our numbers landed. Let's see here. Yeah, you really want to chamfer all your edges here before you even do this stage of it. So let me do that first. All right, let's have one more look at our finished product here. Again, intake, fuel coming down through, going back through the transfers and blowing back at the intake. So took down this side, nice and smooth. Again, same on this side, opposite of the intake, nice and smooth. Intake dropped that floor, got it all chamfered. Exhaust right there, raised the roof, got it chamfered, everything cleaned up, looking pretty good. Let's see what our timing numbers came out to. Okay, no base gasket, so let's make sure that we're still looking close. Top dead center should be somewhere there. Yep. Okay, so let's see what we got. Alright, here's the moment of truth. Alright, the way that the chain spins, exhaust duration, from the time we see first light. See, now it's a nice even light all the way across there too. So, first light here, oh boy, 79. 79. And it's like, it's on borderline 80. So perfect. So 80. After port. 79 to 80, which is 158 to 160. Good, good. Right where we wanted to be, right? Okay, let's just double check that. Yeah, first ray of light right there, right on 80. Okay, good. Alright, blowdown. Blowdown starts right about there. 60, 62. Blowdown, 62. So there we go. We got additional, let's see, so we're at 22 degrees blowdown. We were at 15, now we're at 22. Man, this is all looking really good. Alright, so I was planning on replacing these seals anyway, but I was just doing some inspection yesterday after porting the cylinder, and noticed, I don't know if you can hear that, there's a slight amount of rocking in there. And I wanted to demonstrate here what I'm seeing on this collar, because you've got your seal up against this collar, but see what's happening here? The collar isn't actually spinning. Now if I hold it, I can make it move, and you can see the Sharpie mark there moving around. But it's only when I like force it kind of back and around. Otherwise, I can just move that around. So we'll see if the universal splitter will work on this, just like it does on the Husqvarna. And you've got to get these two cases apart. Of course, I have to take the cylinder off, and then there's a series of flatheads kind of all around here. So we'll get all those out. It looks to be coming apart fairly easily here. You've got a series of screws, and then it looks like a dowel pin. This was just a little narrow. I just took it in the bench vise and pried these open a little bit. But let's see what we got here. Yeah, see, this would have been a problem. And let me show you. Ugh. Looks like somebody was using old motor oil. And I guess, you know, oh, that is still see-through. Okay. There's a sight glass right here that's actually clear, so you can see your oil level in there. But I guess if you have clear oil, maybe that's why they use the old motor oil. Man, that one's going to be gunky, isn't it? Okay. Oh, look at there. Huh. There's like a wire going around in there. I hope that wasn't the seal that was supposed to seal against this bearing. I mean, that moves nice and smooth, but man, I hope this bearing was wore out and not this shaft. Okay, let's try this side here. It really needs to go there. There we go. This side's good and tight. Come on now. Yeah, she's good and tight in there, alright. See, it's up against that. It's up against that. Yeah, I guess I just need a bigger set of boots or something. Yeah, that's tight. So why was this side so loose? Let me get a little taparoo here. Typically helps. It could be all the oil, I guess, on my hands. So this is why you just kind of keep stuff on your bench. Yeah, she is tight. Ooh, I heard it. You guys hear it pop? Yep. Okay. So what do we got here? Looks like a pretty decent crank, but this is what concerns me. See, in this side, it's like tight. It's tight, right? It's not going in there. We're gonna have to, of course, heat and cold. Now the problem is on this one too, I can see the number 6004 S60 IBC. Of course on this one that I'm going to end up needing to replace, there's no number on it. And the difference in the fit up there is pretty apparent when you go like this and it just slides in there, right? See there? And it's actually loose and wiggly against the mating surface there. So I don't know if this is the problem or if this is the problem. We can take some measurements here though and get an idea. So this is a big bearing, like really big. Found a socket adapter. That was actually too big. That fits really well though. Right over it. So I'm just going to give it a few soft taps and then we'll go back to kind of get this ring out. Again, the game plan is to get it to kind of forcibly come out of there. Man, I don't know. There's no holes. I mean, you can barely see the thing in there. It's you can just barely see where you can get your snap ring pliers in there. What are my other options? Trying to pry it out the other way? I guess let's try prying it out the other way. Well, wait, what's going to happen? It may or may not work. We'll try it. Yeah, no, I mean I can see. Yeah, I can see the bearing is completely capturing this. Wants to. Close. Very close. Yep, I think I got it. Yep. Guess that's the way to do that. Alright, let's see, a little smaller socket maybe. There it goes. See there? So I had to pry it all the way around the outside and then like continue to pry it to get it to kind of squeeze out of there. Now we can go back up a size here. Continue to get it out of there. Let's look at taking some measurements off of this here. The main thing I'm concerned about is right here. I just want to make sure that this measurement here, let's see, we're exactly 17 millimeters, but I'm going to use thousands, of course, because I've got the dial. So 0.670. And yeah, 0.670. So it is perfectly, it's perfectly concentric, I guess you could say. Take a couple more measurements here. 0.670. I pulled back on that one. Yeah, 0.670. Okay, so we are completely good across there. Now to measure this, if you've got some machinist tools like this little guy here, you can stick this in there and get it as square as you can. Tighten it down. Let's see, what do we got? Good old Made in USA Lufkin tool. So now you can just kind of come into this. Yeah, so this is 0.669 maybe on here. Yeah, 0.669. So it is just undersized of what this is, but it's only by the smallest of margins. Now the question is this bearing good? Because it's tight. It is tight. And then is the seal good? Now I've got a seal kit for this, but then how do you even get the seal out of there? I guess is the question. And is 1/1000th of an inch too much, or is the surface area across the hole given enough sealing surface? Obviously it's sitting there rotating, right? Look, I can spin the bearing without the race actually spinning. I would think that would be enough to make it not seal, but maybe the surface area contact is enough. I'm going to go see if they've got this bearing down at the bearing store tomorrow. Super hard to read out on there. I'm thinking it's B27908. God, it's so hard to read. So hard to read. GBP mixer. I have no idea. I think it's going to be in millimeters. It looks to be 17 millimeter ID. The problem is this is this is 17, so I don't know what the metric system is for interference fit, but I guess we can try to convert it over to so the ID there, 0.67. Yeah, it's going to be the same here. You can try to convert it over. Yeah, 0.67, and then the OD. Uh, 1.653. That's going to be a tough one to match up. Dang it. Especially without numbers on it. Ugh.